Hello everyone, my name is Karozou. I am a PhD student at the Laboratory of Building Materials in Aristotle University Thessaloniki, and I am going to present to you a small part of our research that was part of the undergraduate thesis of Ms. Atsali, entitled Influence of Hemp and Straw Biofibers in Traditional Mortars. The presentation is divided into 4 parts: the introduction, the methods and the techniques used, the experimental results and discussion, and finally some conclusions that arise from the research. First, let's say a few things for the use of clay and lime in construction. Clay and lime mortars were used in construction for centuries, while they were usually combined as structural elements with wood and stone or with fibers inside their mass for enhancement. Moreover, clay and lime have both been part of the cultural heritage, while clay is a material that is locally abundant, of low cost, energy efficient, and recyclable, granting it as an environmentally friendly material. Same thing stands true for lime as well, since its manufacture produces less carbon dioxide compared to cement, provides vapor permeability, while it can also be recycled and used in other products. However, there are some certain restrictions concerning their use in construction, such as their low mechanical strength and low seismic response, their pure resistance against water penetration, making them susceptible to weathering, as well as their high shrinkage. Moreover, the lack of standards and homogeneity of materials, especially in the case of clay, makes it even harder to use in mortar construction. Moving on, I would like to mention a few things about the thermal insulation capacity and some other terms that can influence it. Thermal insulation capacity is a very important aspect for achieving a thermal comfort and reducing energy consumption, while another term of interest is the moisture buffering capacity, that is the ability of a material to absorb and release moisture from an adjacent space, thus increasing the durability of materials and improving their energy efficiency. Moreover, let's mention a few things about the hygroscopic materials. Hygroscopic materials are the materials that absorb a significant percentage of their weight in water and can reduce indoor humidity levels, improve thermal comfort and air quality in buildings, while also providing low energy consumption. Such materials are actually both lime and clay that are also environmentally friendly, as mentioned before, with great moisture buffering capacity. Now, the materials that were used for the design of the mortars in this study were biofibers of straw and hemp at 1.5% volume per volume, both as additives and as an intermediate layer inside the mass. While the binders used were clay that was rich in calcium oxide from the area of Crete, that was also said to have a grain diameter less than 1/2 of a millimeter, and lime that was provided by a Greek company, Karozou, with a calcium oxide content of 90 to 99%. The aggregates used were washed river sand of siliceous composition and with grain size between 0 to 4 millimeters with no salt content. In total, 10 compositions were manufactured, 5 of clay and 5 of lime, including the reference ones, with a binder to aggregate ratio 1 to 2. The specimens created were of rectangular shape and tiles of the dimensions that can be seen here, while the tests conducted were for both the fresh and hardened properties, as well as the thermal insulation capacity. Overall, the tests conducted were mechanical tests of 3 hardened actually properties, that is, of 3-point bending test, axial compression test, and dynamic modulus, physical tests of open porosity, capillary, and cast-and tube absorption tests, all based on EN standards, as well as a heuristic test in order to determine the thermal insulation capacity conducted on the tiles previously designed, with the use of thermal images before and after heating, as to determine the influence of the fibers, both as an additive and as an intermediate layer. Moreover, heuristic aging tests of wetting and drying and freezing flow cycles were also conducted. Here you can see the composition of the lime mortars with the water to binder ratio, the percentage and the use of the fibers, as well as the workability of the mortars. We can see that L stands for lime, H for hemp, S for straw, and I for the intermediate layer. The desired workability was at 15 plus minus 1 centimeter, while remarkable is the fact that LS mortar with a reduced water to binder ratio presented a higher workability. Furthermore, the same codification tons for clay mortars, as you can see here, while in general, the water-to-binder ratio was lower than that of the lime mortar, except for the composition with the use of hemp fibers that seem to absorb a great amount of water while showing a reduced workability. Here are some images of the intermediate layer of the mortars as to better understand their design with the intermediate layer that was actually between around 3 millimeters. Moving on to the experimental results, in this chart, we can see the compressive strength and the open porosity of the samples at 28 and 90 days. It is detected that the clay mortar with hemp fibers presented early strength development as well as the maximum value of compressive strength in both ages. The maximum value of compressive strength is also developed at 90 days for lime with the addition of hemp fibers. Moreover, it is noted that the use of fibers seems to not play a significant role in terms of compressive strength for lime mortars or porosity. Lime mortars presented the greatest porosity, while porosity values were reduced through time. In terms of flexural strength and dynamic modulus, the mortars with hemp presented the highest flexural strength with both binders used, while fibers seem to enhance flexural strength in almost all cases for clay mortars. The dynamic modulus was increased in 90 days in all cases, while it was reduced for lime mortars with hemp and straw. As far as the capillary absorption is concerned, on 28 days, it is shown here that LS and LSI mortars presented a similar behavior with L, while LH mortar showed the lowest absorption in case of lime mortars, with clay mortars presenting close absorption rates. At 90 days, however, things tend to differ, since L8 and LSI mortars presented the maximum absorption rate, while CS and CSI presented the lowest. However, as can be seen here, the capillary coefficient for both ages calculated according to EN 1015 plus 18, LS and LSI mortars show the highest values of C due to higher absorption rate at 90 minutes. That's actually a bit different from the chart shown before. Now, regarding the cast and tube penetration test, it is detected that the C8 mortar had the lowest and CRHI the highest absorption rate, the latter probably due to its highly porous surface that presented many voids due probably to its problematic design. Moving on to the aging tests that were conducted, were also Heuristic tests, and as a result, the total mass loss after 50 cycles or until destruction was presented. Here it is observed that all lime mortars presented in all cases mass gain, with LH showing the greatest mass gain percentage, while clay mortars had mass loss after the conduction of the aging test, with CHI having the greatest loss value in freeze-thaw cycles. Now let's say a few things and explain the heuristic test of the thermal images. The experiment was conducted on tiles using a thermal camera. The tiles were dry and were also dried further for 24 hours at 40 degrees Celsius before testing. After cooling, thermal images were captured before heating from both sides of the tile and then were heated from one side for 15 minutes using a heating device. Thermal images after heating were captured from both sides of the tiles, and the difference in temperatures on the same side and between sides of each tiles were calculated. Here we can see some indicative images of the reference lime and clay mortars before and after heating. These are some images that were taken. While in this table, the difference in temperatures is calculated, those two values can be combined as to give a certain idea on the thermal insulation capacity of the mortar. Since the difference in temperatures of heating and non-heated surface is high, and the difference in temperatures before and after heating of the non-heated surface is low, it can be concluded for the hemp layer, for instance, that is keeping the heat and not letting it transmit to the other side of the tile. Hence, the great influence of hemp layer in lime mortar, LHI, as thermal insulator is noted, while for clay mortars, CS showed the highest influence as thermal insulator, while for clay, we can see that it's quite stands true in most cases. To conclude, in lime mortars, we can see that the role of the fibers for the stabilization of the mass was beneficial, regardless of the fact that they showed a lower performance in compressive strength with the use of biofibers, but that actually played a non-significant role. The porosity values were significantly high, yet were reduced through time, while positive is the fact that greater values at 3-point bending test were recorded with the use of hemp. In terms of capillarity, hemp lime mortars presented high absorption rates, especially at 90 days, while in cast tube tests, the absorption rate values were lower and close to the reference, except, of course, the LSI mortar. Mass gain was detected after the conduction of all aging tests, with LH having the greatest one, while the hemp layer presented a great influence in a lime as thermal insulator. For clay mortars, the role of the fibers were also proven to be beneficial. They presented better performance in compressive strength with lower porosity values compared to lime mortars, presenting early strength development and lower porosity with the use of hemp fibers, as we can see here. Also, at 3-point bending test, the use of biofibers proved quite beneficial, while also presented lower capillary absorption rates in total, with straw being less absorbent at 90 days. The cast and tube test indicated that C8 and C8I mortars had the lowest and highest absorption rate respectively, while after aging tests, the specimen suffered mass loss, with fibers having in general a beneficial role. The C8 mortar had the highest influence as thermal insulator, while for clay, as previously discussed, stands true in most cases. Thank you so much for your attention. I hope you have enjoyed the presentation and find an interest in it, and hopefully I will see you soon in Rome, ready to answer any questions. Thank you again.